A very good day to all. This is Group 6. We are going to present about real-world accident, that is Tempi train crash 2023. This is our group members. For the introduction, the accident happened on 28 February 2023 at Tempi Valley, Northern Greens. It was a head-on collision between Hellenic train, passenger service IC62, collided with intermodal freight train. It was a massive derailment and fireball. 57 were killed and dozens injured. Most of the victims were university students.
So I will present about BOTA analysis. So in BOTA analysis, we have top event, which is the head-on collisions between a passenger train and a freight train. For the hazard, we have operation of passenger and freight trains on shared railway lines. So we look at the left side. We have the threats of the cases, and each of the threats preventive barrier. While on the right side, we have the consequences of the case and also each consequences reactive barrier that will be explained further. So for the first cause of this event is human error, which the station master misrouting the train. So from the official report, found that the station master did not use the rudimentary or so-called automated system, and instead he performed a manual routing, making an incorrect switch setting. So from this manual error, it directly routed the train, IC62 train, into the path of the oncoming freight train. Because of the safety interlocks and automatic route checking system were absent, the passenger train was allowed to proceed despite of the conflict. So from the human error of misrouting, thus directly set both trains on the head-on collision course. Causes is non-functioning automatic signalling and control system. So the railway's automatic signalling and control system were inoperative. In the Tempi incident, the color light signals on the relevant track were broken and permanently showing red signal. Also, no automatic control was available to manage the train separation. The third causes is outdated communication system. For the Tempi train crash, the outdated communication contributed to confusion about the freight train's location and the schedule. Without a modern communication link, the station master had reduced situational awareness that increased the risk that a misinformed routing decision would go unchecked. No maintenance routine, and as the railway's maintenance culture was largely reactive, there was no regular preventive maintenance schedule. Infrastructure was repaired only after a breakdown occurred. This neglect allowed critical components such as signaling cables, lights and switch mechanism to deteriorate unchecked. In this case, systemic maintenance failures can be seen in the stolen or damaged signal cables and perpetually out of service lights. The absence of maintenance meant that what might have been fixable issue like the broken red signal or faulty power supply become chronic problems. And lastly, excessive workload and technical issues. On the night of the crash, the station master was reportedly handling numerous tasks. After an electrification fault disrupted service, he had to manually coordinate multiple track switches to route trains around the problem. He was also working a long sequence of night shift, which contribute to the fatigue. Each technical issues like the faulty power line and inoperative signals require extra attention and created a time pressure. This workload made the human error far more likely. The station master mental workload and tiredness meant he failed to notice that the two switches remained incorrectly set. In short, when staff are overburdened by repeated disruption and long hours, the risk of oversights or lapse in judgment grows, and that contributed to the accident.
Hi, my name is Siti Ansha, PA22052. Here is the main consequence of...
Hello, and I will explain to you the lessons learned. Let's get started. Now, the number one is infrastructure neglect is dangerous. This is deferred maintenance and outdated equipment is increased risk. Continuous funding and modernization such as rail, signals, communication is essential. Safe railways can become unsafe if upgrades stall. The second one is automated safety systems are critical. In the absence of ETCs and remote braking was a key missing barrier. The reliance on manual procedures is not enough, and the fail-safe system must be integrated to prevent any human error. The third one is human and organizational factors matter. Individual mistakes often occur within broader system failures. Training, fatigue, and interface design must be addressed. Next is to promote a culture where unusual situations trigger caution, not routine. Number 4 is independent oversight is essential. Lack of independent investigation limits root cause discovery. Transparent, unbiased reviews help fix systemic issues. Third-party accidents investigators should be standard. And the last one is the use of formal risk analysis, which is the bow tie. The bow tie diagrams help visualize failures and missing barriers. It encourages proactive identification of risk and safeguards. This should be used across industries for structured risk management. Thank you.
Preventive measures that could have been taken to prevent future incidents like the Tempi train crash. Several key preventive measures I will be proposing. First, the automated interlocking system that ensures trains are routed safely by controlling signals and switches automatically, which reduce the chance of human error. Second, the dual operator rule will add an extra layer of safety by requiring 2 operators in the control room. So, decisions are verified and mistakes are caught early. Third, regular inspections and testing of signal system are vital to detect faults before they lead to accidents. This helps maintain the reliability of critical railways infrastructure. Next, upgrading to modern communication systems, including radio-based and real-time digital networks, will enable faster, clearer, and more accurate coordination between train drivers and control centers. Lastly, scheduled preventive maintenance programs combined with adequate staffing ensure that equipment is always in optimal condition and there are enough skilled personnel to manage railway operations safely. Together, these proactive measures aim to prevent disasters before they happen by strengthening the system at every level. Thank you.